And now I'm ready to install the main shaft and rotor head into the main frame of the helicopter. You need your main gear, your rotor head and main shaft of course, along with the included shims that come with the Align kit for your main shaft. There are various thicknesses and they allow you to shim the shaft so that there's no free play up and down once you've got it installed into the bearing blocks. So what you need to do is install the main gear, then drop the main shaft down through your 3 bearing blocks, install your lower main shaft bolt, and then pull up and down on the main shaft. If you have a little bit of up and down free play, you need to use a thicker one of these included shims. If you can't get the lower main shaft bolt in, or you have to force it down to get it through, then you need to try a thinner shim. So there's no collars, no set screws, none of that stuff that you have to play with trying to get set screws and tools in between main shafts and servos and frames. So once it's all said and done, it's absolutely perfect. It's going to take a couple tries before you get there probably, but once you're done, that's it for your basic mainframe assembly. Here's our factory pre-built tail rotor case as it comes out of the box. A couple differences between this and the previous V2 version. First, we have an aluminum anti-rotation bracket. That pin is never going to snap off in a crash like the plastic one sometimes does. Secondly, we've got a new bell crank setup. This one grabs our tail pitch slider here, both the top and the bottom, and is fully supported by bearings both on the pitch slider and on the idler here. So there's absolutely nowhere to develop any slop. The only thing that you need to do is pull out all of these bolts individually, Loctite them, and then reinstall them. It's easier to do it individually, that way you don't have to pull everything apart and then figure out how it goes back together after the fact. So I'm going to Loctite all the hardware on this, and then we're going to install it on the back of the tail boom, install the torque tube, and then put it into the main frame of the helicopter. With the tail rotor case all Loctited, we're ready to install the torque tube into the tail boom, put our links on our push rod, and install the guide onto the tail boom. At this point, something worth mentioning is the bearing placement in the torque tube. I've glued the bearings to the torque tube here and then slid the rubber bearing hanger over top of the bearing. You need to make sure that the bearings aren't equidistant from the end of the torque tube to the bearing or the bearing to the bearing. If you make everything symmetrical, you're going to set up a tail rotor vibration. So just make sure that they're offset by 10 or 15 millimeters either way so you don't run into that issue. I've got a little bit of tri-flow here that I'm going to spray on the rubber bearing hangers on the inside of the tail boom. That's just going to make everything go together much easier instead of having to force it down through. You can use motor oil, a little bit of fuel if you've got a nitro model, soapy water, anything to make that a little bit easier. Once we get the torque tube in, we'll make sure it's spaced equally so we've got the same amount of spline showing on either side, so we have equal gear engagement in both the tail rotor case in the back of the model and the tail rotor case in the forward frame part of the model. So I'm going to put this all together and then we'll look at the next step. When the time comes to install your boom supports, I suggest that you bolt them to the lower base plate before you install them onto this fin bracket. Leave the bracket loose enough that you can slide it back and forth easily so that when you do bolt the boom supports up to it, you ensure that there's no preload on the boom supports. Once you've got these bolts tight, you can visually reference from the back of the helicopter that this horizontal fin is in fact horizontal by lining it up with your canopy standoffs. Once that's done, you can install your tail rotor control guide, and I like to install this before this just so we make sure it doesn't interfere with this or the boom supports in any way, shape, or form. I've got a few basic setup tools laid out here, and I'm going to go through some quick setup tips that are outlined in the manual, but it's definitely easier for you if you can see it here firsthand. I know it is for me, being able to see something and have someone explain it opposed to reading it in a manual. So our first tool is a caliper or a ruler. You don't have to have the caliper, but it's definitely a little bit nicer. I've got the Align digital pitch gauge. You can use any pitch gauge, it doesn't have to be digital. And I've also got a swatch plate leveling tool. These two tools are going to go hand in hand. By having one, you may not necessarily need the other, but it's nice to have both of them just to reference and verify that all your linkage is set up correctly. So the first thing we're going to do, regardless of your flybarless system, I'm using the 3GX here, but you need to power on your radio system and center all your servos. You want to flip-flop all your servo arms around so that you get the best 90-degree situation without using any sub-trim. So the kit comes with 3 aluminum servo horns. You should try each one on every servo to get the best possible scenario. 5-10% sub-trim is okay, but we'll try not to exceed that. So once all of your servos are centered, then you can go ahead and make sure that all of your cyclic servo linkages are the exact same length, and that's where this caliper is going to come into play. By doing so, you probably won't have to use your swash plate leveling tool, but it's very easy to verify that your swash plate is level by using this after you set your link. Once you're satisfied with your servo centering and you've got everything sub-trimmed out to where it's at 90 degrees, we need to adjust our cyclic linkage rods to all match. I ended up being at 2.4 centimeters, so all you need to do is take your caliper and verify that all your linkages are exactly the same length. This is going to ensure that your swash plate is perfectly level, and also put the swash plate in the center of its travel, so you're going to have a symmetrical positive and negative pitch value. Also at this point you can adjust your DFC links to give yourself 0 degrees of pitch at half stick, which is where this pitch gauge is going to come into play. That's it for the build video on the 700 DFC. I hope that if you are considering this product, it's made your decision a little bit easier. All in all, it's a very, very good complete package. Everything that comes in the box is going to make this helicopter flight ready, so you're not having to purchase anything separately. The model has exceeded all of my expectations, both in flight characteristics, reliability, ease of build, the simplicity. All in all, just a really good package. So once again, I hope you consider this product if you're in the market for a 700, and we'll see you next time on another build video.